Hi everyone, this video is about the measures of centrality, and if you want an overview of all the things that you would need to know about measures of centrality, I've got this page up in the notes on Canvas, but I also expect you to be able to know how to find these in GeoGebra, so I'm going to go over how to find all four of these so you know what tools to use. The first one is going to be the centroid, or the center of mass. This one connects the midpoint of each edge to the opposite vertex. So if you've got your triangle up here, you're just going to use the midpoint tool, then click on each of those lines, and then make a segment that connects this midpoint to the opposite vertex, opposite vertex, and that's going to be your centroid in the middle there. Okay. The next one is the incenter. That's the one that has this in circle, and that's going to be centered at the incenter. You're using the angle bisector tool, but it says select 3 points or 2 lines. I'm going to select 3 points. So finding this angle, cutting that in half. I'll do that for all 3 sides. And that's going to be your incenter. Next up is the circumcenter. That involves perpendicular bisectors. So these are perpendicular lines that cut each of these in half. All you need to do is just select the perpendicular bisector tool and click on all 3 edges. In this case, you can see that the perpendicular bisectors all end up meeting down outside of the triangle, and that's okay. That's possible for the circumcenter. So again, just clicking on all 3 of these, they should end up converging at the same spot. For the orthocenter, this is the only one that really needs some more explanation. So if you look at this triangle that I've got here, the altitudes that you use to make this line, they're always perpendicular to the edge, and then they go through the opposite point. So for example, this edge down at the bottom here, this line is perpendicular to that, and it goes through this opposite point. It might be helpful to think about these perpendicular lines as being like perpendicular lines when we talked about slope, right? So it's not necessarily going to form this nice 90-degree angle with the edge. It's just going to be pointed in a 90-degree angle away from that. So the tool that you're going to use for this is the perpendicular line. So it says select a perpendicular line and a point. I want something that's perpendicular to this line, and I want it to go through this point. So that's one of my altitudes there, and that's the one that kind of makes the most sense. But if I click on this one, I need a perpendicular line over here, and I need to connect with that point over on the right, which is over here. But you notice that I'm not actually connecting with the edge anymore. But that's fine as long as it's perpendicular to this line, so facing this direction and connecting with this opposite point. I'm going to do that with the last one as well, so I want it perpendicular to this line and connecting with this point opposite that. So if all these kind of lines are a little bit too much for you to process, all you need to know is selecting the perpendicular line tool, click on an edge and the opposite point, edge, opposite point, edge, opposite point, and that's going to give you your orthocenter with those 3 altitudes. One last thing that I wanted to go over is Euler's line. So you can see I've got all 4 measures of centrality here. This one is going to be my incenter. This one is going to be my centroid. So down here is my circumcenter. And this one up here is my orthocenter. Now, depending on where I have these 3 points of my triangle, these are all going to be in different spots. But the one thing that's consistent, regardless of what the triangle looks like, is that these three, the orthocenter, centroid, and circumcenter, are all going to be on this line, and we call that line Euler's line. It is possible for that incenter to also be on there, but that only happens when we have an isosceles triangle. So I'll show a exaggerated version of that. So here's my isosceles triangle. We've got two long sides and then a short side down here, and all four of them are going to be on that line. One last point about Euler's line. Euler's line doesn't really become a line anymore if we've got an equilateral triangle. If you have an equilateral triangle, then all four of those measures of centrality are going to be at the same point. All right, I hope you found this video helpful, and you can expect to see a problem or two like this on the exam where I ask you to find one of these four.